Okay, now we're going to take a look at the first application of differentiation, which is dealing with the slopes of tangents. So we can use differentiation to help us figure out the slopes of tangents of functions and hence the equations of tangents of functions. So let's say we have some cubic function. Let's start off with a cubic function. Y equals ax cubed plus bx squared plus cx plus d. So this describes any cubic function, and we have an example of our cubic function here on the left. So we know how functions work. You input the x value, so you can input any x value you like. So if you take a cubic function and you input any x value you want, what is the output? All right, so what is the output of a function? All right, and you know that you put in the x value and then the output of the function will be the y value. All right, so you put in your x value and the output is the y value. So your input is the x value, your output is the y value. That's how functions work. All right, when you want to relate it to the graph. Put in the x value, output is the y value. Now let's say we differentiate this function. All right, so I'm going to differentiate this function and I will get dy dx equals 3ax squared plus 2bx plus c. All right, dy dx is 3ax squared plus 2bx plus c. Now what if I input the x value in here? What is my output when I input the x value into my derivative function? So what we need to understand is that dy dx is the slope. dy dx is the slope at that particular x value. So if you input the x value, your output is actually going to be the slope of the tangent at x. So we input the x value and the output represents the slope of this tangent at that x value. So your input is the x value and your output is the slope at that particular x value. And at different x values you will have different slopes. So the important thing to remember here is that dy dx represents the slope of the tangent line at the particular x value along the function. And at different x values you will have different slopes. So let's take a look at an example of what we've just been learning. So I will have a look here at question 7. What is the equation of the tangent to y equals x cubed plus 3x squared minus 6x plus 4 where x is equals to 3? So I'm asked to get the equation of a tangent. So over here on the left I have the function x cubed plus 3x squared minus 6x plus 4, and I need the equation of the tangent where x equals 3. So we have x equals 3 here, and I care about where x equals 3 on the function. So on the function, if I go up, x equals 3 right here. So the point we're talking about is this point on the function. This is the point, and we want the equation of the tangent at that point. So we want the equation of this particular tangent right here. That red line is a tangent to the function at the point where x is equals to 3. So that's what we want to get. We want to get the equation of that tangent right there. So I want to get the equation of a tangent, and we know that a tangent is a line. So I'm dealing with the equation of the line formula, y minus y1 equals m bracket x minus x1. That's the formula I'm going to use. And in order to use that formula, I need to know a point, which is my x1, y1, and I also need to know the slope, which is my m. So the point, well, what do we know about the point? We know it's the point where x is equals to 3. So we know the point is the point 3 something. How do we get the y value? We fill into the original equation. Now the original equation, the original function, y equals x cubed plus 3x squared minus 6x plus 4. So we're going to fill into y equals x cubed plus 3x squared minus 6x plus 4. Fill in the input to get the output. So y is equals to 3 cubed plus 3 times 3 squared minus 6 times 3 plus 4. Working through that, we'll get y is 40. So looking over here, we fill in our x value of 3 and we got the corresponding output y value, y is 40. Therefore, this is the point 340. So we have the point 340. Now we have to get the slope of this red line, this tangent. And remember, dy dx is the slope. The derivative is the slope. The derivative represents the slope at x. So we get our dy dx by differentiating the function. dy dx is equals to 3x squared plus 6x minus 6. Now this describes the slope at all points. We care about the slope specifically at the point 340 where x equals 3. So at the point where x is equals to 3. Our slope therefore will be 3 times 3 squared plus 6 times 3 take 6. So our slope is 39. So we want to get the equation of the tangent. We're using the equation of the line formula. We needed a point and the slope. We have our point here, the point 340. That would be our x1, y1. And we have the slope of 39. So continuing this on, we have the point 340, the slope 39, filling into the equation of the line formula. Y minus y1, y minus 40 equals m 39 into x minus x1, x minus 3. And we can tidy this up to 39x minus y minus 77 equals 0. And that is the equation of this red tangent line that we see on the image right here. So that is our introduction to the first application of differentiation slopes of tangents. The best thing for you guys to do is have a look at some of these questions here. Keep an eye on your solutions. And for access to questions, solutions, graded quizzes and more, visit www.lumymaths.com.